Hi guys, so today we're going to be transforming formulas. Now, we've been solving equations, and now what we're going to be doing is we're going to be looking at how we can manipulate formulas so that they are, we're solving for one variable in terms of the other variables. So let's look at an example, because I think it's usually easier if you can see it by example. It says, solve the formula F equals MA. So I'm going to write it down here, actually. F equals MA for M. That means we want to isolate M. We want to get M alone on the other side. So to do that, the first thing I'm going to do is I'm just going to divide both sides by A. Now remember, M is being multiplied to A, so we would do the opposite operation. The A's would cancel, and so F over A equals M. Okay? But now we've got to look, it says state the restrictions, if any, for the formula obtained, meaning the new formula, to be meaningful. Well, this formula is a fraction. It has a fraction in it. So in order for it to be meaningful, it means it has to work. Can you think of a number that would, if it was in the denominator, would make this fraction not work? Well, hopefully you're saying that if A was equal to 0, then this would not be a meaningful expression. So we're going to state that A cannot equal 0. And that's the restriction that we have on this formula. Okay? All right, let's look at a harder example. Number 2. The formula A equals 1/2 H, A plus B, gives the area of a trapezoid with bases that are A and B units and with a height of H units. Use this formula to solve for the variable B. We want to solve for B in terms of A, H, and A. So it's going to be B equals something. Now, here's the thing. When we are solving equations, we always usually distribute first. But we have to be really careful when we're transforming formulas, because if we distribute, that actually makes the problem harder. So the first thing I'm going to do is I'm going to try and get rid of this 1/2, get it over to the other side. So how can I do that? Well, I can multiply both sides by 2. So I'm going to multiply this side by 2 and this side by 2. When I multiply by 2, it's going to cancel the 1/2 on the right side. So now I have 2A, let me switch colors actually. 2A equals H, A plus B. Now remember, our goal is to isolate B, okay? So now I want to get the H over to the other side. And again, you don't want to distribute unless you absolutely have no choice. So because H is being multiplied to this whole quantity, I can divide both sides by H. Okay, so I'm going to do that. Divide both sides by H. Now, this H cancels and I have 2A over H equals A plus B. All right, that looks a little bit prettier for us now. So, how am I going to isolate B? How am I going to isolate the variable? I'm going to subtract A to the other side, okay? So I'm going to subtract A. Now, it's not going to go as part of this expression. If I subtract A, we're going to put it outside the expression equals B. Okay? All right, now we have to look at the expression and see if there's a variable or a restriction that would make this equation not work. And hopefully you're seeing we have a fraction. We can never have a 0 in the denominator of a fraction. So H cannot equal 0. All right. What I want you to do on that first page now that I've done 2 examples, I want you to do numbers 3, 6, 9, 11, and 12. Okay? All right, I'm going to do one more example once you finish those. Okay, so we're taking the equation C equals mv squared r, and it says solve for r. Okay? So the easiest way to solve for r if it's in the denominator, okay, is that we want to get it out of the denominator. So we can do that by clearing fractions. So I'm going to multiply both sides by the LCD, which is R, okay? And so now the R's here are going to cancel, and I'm going to get RC equals MV squared. Now, we're solving for R, so now R is being multiplied to the C. I need to isolate it by dividing both sides by C. The C will cancel, and we get R equals MV squared over C. All right, and at this point, we should see that C cannot equal 0, so that's a restriction on that equation. Okay, a few more problems I'd like you to try. I'd like you to try numbers 17, 20, and 21. And we'll go over those, and I'll give you the answers tomorrow. I'd like to see how you can apply what you just learned. Have a great night.